Hello, Year Nines. I hope you're well. Welcome to this week's Loom lesson. Thank you very much to Mr. Johnson for last week's Loom lesson, where I think he did a really excellent job of breaking down that exam question. And I think his musical choice was fantastic as well. And then the work that he did with fluvial processes, those river processes, I hope you found that was really, really valuable. Now, this week we are moving on. Let's go to the slideshow. Our learning question: what can I remember about river landforms? So, first of all, please make sure you have a pen, pencil, and some paper to work on, and that you're ready to roll. And to get you in the geographical mood, let's have a countdown challenge. Last week with Mr. Johnson, you went through the 4 processes of erosion, the 4 processes of transportation, and also deposition. What I've done here is I've picked 2 of the processes of erosion, 2 of the processes of transportation, and the term deposition. So quickly from memory, write a definition for any one of those 5 geographical terms whilst I press the music. Off we go. Okay, so how did you get on? Let's take a look, shall we? Let's go through these. So first of all, let's look at the processes of erosion. So that's either vertical erosion, so downwards, or lateral sideways erosion. And the first of those terms there, abrasion. Now, I know that Mr. Johnson came up with a really, really good way of remembering this, where he was talking about abrasion being the scraping of the load carried by the river, where it repeatedly scrapes across the bed or the banks of the river, dislodging particles into the flow of the river. So that's your definition of abrasion. Next up, hydraulic action. Now, hydraulic action, that's where the force of the water hits the river bed and banks, and that causes either cracks in the rocks or the river bank. Really most effective when the water is moving fast and when there's lots of it. So that's the definition for those 2. How did you do? Check what we've written against the definitions I've just given. Whilst we're just covering off those processes of erosion, let's just recap on the other 2. So that's also attrition. So that's when stones carried by the river collide against each other, gradually making the stones smaller and more rounded. And then also solution, which is where the river flows over limestone or chalk and the rock is slowly dissolved in the acidic river water. So that's covered off erosion from last week. Let's look now at the 4 types of transportation, starting with the 2 definitions here, one of which you could have picked for the challenge. So first of all, suspension, which is the finer material that floats in the water. Traction. Mr. Johnson was talking about obviously the movement of larger boulders in the river. And he was using the example for remembering traction of the wheels on a tractor slowly rolling across the field there, and making you think about the fact that larger boulders are slowly being transported. Obviously they're heavy, and they're slowly being transported within the river. The next one of those, it's deposition. But before we get on to deposition, let's look at the last 2 types of transportation, just remind you of those. So we've got siltation, which is where pebbles bounce along the riverbed, and then solution. So that's minerals which are dissolved and carried in the water. And then, yeah, finally, deposition. So that's the dumping. When the river velocity, when its speed decreases and there's no longer enough energy to transport the load, so it gets dumped. Okay, how did you get on? If you need to address any issues there, just please take a moment, perhaps use a different color pen and just check through your work and make any alterations as required. And I'll see you in a moment. Okay, so what are we going to be doing today? Well, first of all, we're going to be recapping how to identify and explain the formation of meanders, oxbow lakes and levees. We could have included V-shaped valleys and waterfalls in this, but I've decided to focus on meanders, oxbow lakes and levees. First of all, because I've looked back at some of the mistakes made in the assessments, and so we can correct some of the issues there. Also, with regard to levees, we're moving on next week with the next Loom lesson to explain the management of river flooding. So let me just take a glass of water now because I'm losing my voice. That's better. Thank you. So yeah, it will seamlessly move into the next week's Loom lesson, and what you learn here will be really, really useful for that. Overall, it's going to help deepen our knowledge of rivers, an important section of the GCSE syllabus, to make sure you can really make the most of the opportunities in your exam. And today we're going to do that by looking at the physical processes in detail, annotating some diagrams, and answering questions to demonstrate knowledge. So the focus of today is in the lower middle course and into the lower course of the river itself, where the river becomes the estuary and meets the sea. We're going to be looking at these landforms, levees here. And if we go back up to slide 1 again, we can see that this is a picture of the lower course of a river. How can we see that? Well, first of all, let's just take a look on the sides here. These raised riverbeds along the river here, so we've got them on the outside and also on the inside bend. They are our levees, and we will look more as we go through this lesson on how they're formed. We can also see the wide, flat expanses of land either side of the river. If you think back to the work that we did 2 or 3 weeks ago on the River Tees, and I highlighted that as we got into the lower course, these wide, flat expanses of land were very fertile areas and very good for arable agriculture, and you can see evidence of that here. And also we can see the river is particularly wide, the river channel is wide, as the meanders erode the valley sides, and then we end up with this wider channel in the lower course. Okay, so as you can see in the middle reaches of the river, the vertical erosion decreases its importance. We're looking at more lateral erosion and deposition, and then in particular today in the lower reaches of the river, more fine material is deposited, and deposition is far more important than erosion. Okay, what I'd like you to do now is to take a look at a couple of videos. I did try recording this earlier, and I did actually play the videos. Now, it must be something to do with the position of the speaker on my laptop, because the audio when I played it back was absolutely terrible. So what I suggest you do is you pause this video now, and you watch both of the YouTube clips yourselves. The first one starts at about 45 seconds in. It's actually quite well worth rewinding a little bit further back. It will talk about muskrats. Now, muskrats are not native to the United Kingdom, and you'll tell by the accent of the person doing the narration that I think it's probably American. Here we have water voles that would do exactly the same job as the muskrat, so it is still hugely relevant to what we're doing. So I'll sign off for a moment, pause the video, and then when you've finished, we will resume. I will see you shortly. Okay, I hope you found both those videos really useful and you made some good notes from them. I've just put this image up onto the slides. Don't need to worry about copying this down. You should actually have a copy of this from work that you did earlier in the school year. But it's a really good one just to remind us of what we're doing, and that's why I've included it. First of all, using the information you have already and you've just got from those 2 YouTube clips, let's consider what we're looking at here. First of all, you can see on the River Cliff that we've got some cracks starting to appear up at the top here. As you're seeing that the bend is being undercut there by that lateral erosion. Similar principle to that of a waterfall. Obviously, we haven't got a difference in harder and softer rock here, but you can see that it's undercutting, and what's up here on the top is going to crumble away in the not too distant future. Obviously, as a result of hydraulic action and abrasion. Similarly, on the inside bend here, you can see the depositing of sand and shingle. So that's your siltation. It's, I think, really good to look at this cross section and just to take a stock for a moment to fully understand that this is describing the process of the development of your meander. Okay, so first question time. What I'd like you to do is to explain why a river deposits its load. It's a 2-mark question. Think about the processes that occur for this to happen. You might like to refer to where in the river that this is going to happen. Perhaps start your answer with deposition occurs because. Now, I would suggest that you may wish to pause the video for a moment. You could look at the videos again if you want. You could also check out the textbook pages that I've included on class charts as well for any further information that you might require. If you are not pausing, then you may wish to listen to this little musical interlude because, as you would expect, now we've started a tradition that there's got to be a river song in here. And so you could carry out your 2-mark answer in the time that it takes for the song to complete. But before we do that, I have a request for you. In order to make these Loom lessons a little bit more interactive and hopefully a little bit more interesting, I'm going to invite you during this next week to email me with any dedications that you want to make. So, for example, if you know a fellow geographer has a birthday coming up and you'd like to wish them happy birthday, or if you just think somebody needs cheering up, or if somebody hasn't been well and you want to send some best wishes that they're getting better, then email me at r.joy@hasler.org.uk. While we're at it, let me start off with a dedication. I'm going to dedicate this next really mellow tune to one of us that has got a birthday this very week. And I know she will be tuning in and listening to this. And I know she'll be quite embarrassed when I say that she's 21 again. Miss Bishop, happy birthday this week. I hope you have a fantastic day. Right, guys, let's have a look at that question. Here comes the music. Off you go. Okay, so that was Groove Armada with At the River. Very aptly titled, I think you'll agree. Right, so let's have a look at this one then. Explain why a river deposits its load. What could we be including in that 2-mark answer? Well, first of all, deposition occurs because there is a reduction in speed. So the river has lost energy. You could put a reduction in the amount of water. That would also be valid. And yeah, the reference to where this may occur. So, for example, a change in gradient. So as we reach the lower course, and of course it smooths out, and where the river flows into the lake or sea, because the sea absorbs a lot of the river's energy. So I hope that what you've put reflects the information and the detail we've got down here at the bottom. If you want to take a moment to redraft or edit what you've done, perhaps using again a different color pen, please do that now, and we'll pick up again in just a moment. Okay, so on to the next bit of work. This is a 4-marker. Now, you may wish to just draw these 4 images onto a plain piece of paper to answer your work, or you may wish to, if you have the facility to do so, to print a copy off from Class Charts, because I've put a copy up there for you, should you be able to do so. Now, I'm not going to go through the answers to this one today. We'll do that on next week's lesson. So I want you to give this one a bit of thought. I've put the mark scheme in there. 2 different levels. So we've got level 1, which would be a basic answer that would get between 1 and 2 marks. So some knowledge of basic information. simple understanding, but very limited links. And what we do need to be doing is linking these processes, because if you think it through, then we're looking at the stages of the formation of the meander and then the creation subsequently of the Oxbow Lake. And if we look at the level 2 mark scheme, so 3 to 4 marks, it's clearly stating that we're looking for a sequence and formation of the Oxbow Lake, that it's clear that you've stated with the 4 different answers how we've got from the first part down to the end. And some linkages as well. Clear evidence of sentence structure. So take a moment. You may wish to try and do it from memory first, just to test yourself, and then actually go back through some of the content, the videos and the textbook pages, and then test yourself. Look at your first example, use a green pen, red pen, whatever you've got available, and then be able to chart your own progress. And then we'll go through what I would be expecting from a level 2 answer in next week's Loom lesson. Okay, good luck with that. Give it your absolute best shot. So we're moving on to look at levees. So we're here into the lower course of the river, surrounded by the floodplain, the area that would be naturally affected by flooding if the river rises above its banks. It's the point at which the river meets the estuary, so your transition from river into ocean environment. And levees, these are the ridges of sediment deposited naturally alongside the river by overflowing water. But how does it happen? Now, again, I'm not going to run these videos because I know we will get absolutely terrible audio. Although I tell a lie, let's run this first one because there's no audio. This is a silent film. It's a Charlie Chaplin type thing. Let's run this one, and then I would suggest that you log on and look at this one yourselves. It's a particularly good video. I really think this one is superb for getting the sort of content you need at GCSE level. But let's quickly look at this one because I think it's really useful. Okay, so take a look at the second video, the Mrs. Geography video. Pause this and then come back to me when you've done that. See you soon. Right, so hopefully you've made notes on those videos and you've started to get a much better idea as to how a levee forms, which will be really useful because I've got another 4-mark question for you. Explain the formation of a levee. As you can see, it encourages you to use keywords that are listed in your answer. So deposition, floods, so that's obviously an event that takes place in the formation of a levee, build-up of layers and loss of energy. Hopefully that Mrs. Geography video in particular will be really helpful to enable you all to get some really corking answers for this. Bear in mind that it's asking you to explain, so it's asking you to give reasons why it's happening. So probably start this one off along the lines of a levee is formed as a result of. Now, again, I'm not going to give you the answer today, the model answer. Take this away. We'll look at it in next week's Loom video lesson. Good luck with that. Give it your absolute best shot. Now, if you've got any queries about the content of today's lessons, please go to your main class teacher. And don't forget, if your main class teacher is Miss Bishop, do wish her a happy birthday. If you've got any queries with regard to the Loom itself and being able to access it, or any technical things, then please come to me, as I am the originator. I've also put an extension video on there for you, which is another one of those Mrs. Geography videos. This one's about interlocking spurs and V-shaped valleys. Again, a really, really good, very valuable, very well constructed thing to watch. Okay, so first of all, please do get in touch with any dedications for next week. Let's try and make these Loom lessons as interactive as we can possibly do. It looks like we're going to be doing them now for quite some time. It doesn't look as though you're going to be back in school for quite some period of time. So these things are going to be really important, and the more fun we can make them, the better it's going to be. So yeah, please do get in touch with any dedications. Also, any suggestions for river-based songs at the moment. Maybe you can come up with something that is more to your musical taste than the stuff that Mr. Johnson and I have been coming up with. So please do make those suggestions. It's really, really encouraging to see so many of you are tuning into these. But if there's anybody, any fellow geographers out there that you know that still aren't, please encourage them to do so. Like I say, this is obviously going to be carrying on for some time now, so I think it's important that we really keep up with the content. In the meantime, stay safe. Thanks for tuning in, and I will look forward to hearing from you guys soon. Bye for now.